Now, before we go into the calculator thing though, make sure you understand or you identify these important buttons on your calculator. First, there's a caret button. This is called the caret button. That's a upside down V, and it means raise to the power of. Okay, it does the same thing as in other calculators. You'll see x to the yth power. This is the exponent button. And on some other calculators, it's y to the x. I believe these things do the same thing. And then you also should identify the equal sign or the equal key or the button, which does the same thing as the enter button. Your calculator should have one of these. And so make sure you identify those before we go on to these problems. Okay, number one, what is the balance in 10 years if you deposit $500 today in an account with 5% compounded monthly? And so if you look at lesson 7, you see this is a formula you use. It's monthly, so you have 12 in the denominator. And let's identify these numbers in the word problem. 10 years, what is 10 years? Okay, this is what we identified as n, the number of years. Okay, and by the way, you should also note that this is one of those problems, it's a problem from section 7 or lesson 7, which is a one-time deposit, okay, not a series of regular equal payments like the next two problems. All right, $500 is the initial deposit. We denote this with P naught, and then you have 5%, which you write as 0.05, and that's your R. And then monthly means K is equal to 12, right? And that's what you're seeing here. All right, now, as you try to find this answer here, how much would you have if you start with $500, and then wait for 10 years with 5%? This is what you need to do first. Okay, that's called the rate per period, and it's the annual percentage rate divided by 12. Okay, so we went over this in lesson 7. And then you add 1 to it because it's in the parentheses. And then you raise to, not multiply this by 500. Don't do this yet. You raise it to this, which is 120, okay? Because the order of operations in mathematics requires that you do this exponent first. And then finally, once you have everything in this green box, then you multiply that by 500. Get that? It is a very important point. Okay, so as I will show you in just a second, what I will do first is to do 0.05 divided by 12. And you can put equal sign, or you can just add 1 to it. I know that the problem says 1 plus this, okay, but that's the same thing as this fraction plus 1 because because addition is commutative, which means 1 plus this is the same thing as this plus 1. And then you want to put equal sign here because once you want to stop these calculations after you find what's in the parentheses, and then you get your answer, right? Whatever the answer is. And then you raise it to the caret button or x to the y button, and then you do 120, which is this part here. All right, and then equal sign. This will give you whatever is in that green box. Okay. And so right here, you stop your calculation for a little bit, find out what the green number is. Okay, and that's going to be bigger than 1, obviously, because you're raising this number, which is bigger than 1, to a positive power. And then you multiply this by 500. And then put the equal button. So this is pretty simple. All right. Now I will show you how to do this how to do these operations on your calculator. Okay. So this is how this is to be done. I hope your calculator will look something like this. What you're seeing now is the scientific calculator that comes with the any PC that has the Windows operating system. Okay, so the equation I had says 0.05. Oh, that's not 0.005, right? So let's erase that. 0.05. Okay, and then you divide it by 12. I didn't go on. All right, let me go from the beginning. 0.05, and then here's division divided by 12. And this will not be a nice number. Okay, you see this number here. It has lots of digits. And then you add 1 to it. So this is inside of the parentheses. And you see this button here, X to the Y. This is your caret button. I'm about to raise this number to 120th power, okay? And you can see what I am doing here. Just, I mean, this is showing you what calculations I'm doing. If I put the equal sign here, this will tell you everything in that green box I told you. And then multiply this by 500. And what you see is the answer, which is $823.50. You can truncate everything that is after the penny, right? So you can say the answer is $823.50. I hope you get that, all right? And this wasn't too bad. The next problems will be a little more complicated. All right, so the answer we got was $823.50. All right, and then you want to make sure that this is sort of reasonable, and it is because you have $500 with a pretty good rate of 5% for 10 years. If your answer happens to be less than 500, you know that's not correct. If your answer is negative, that's not correct. If you get an answer that's like billions and billions of dollars, then that's not correct. Okay, now again, don't take this don't do this one first and then raise it to the 120th power, because this will give you a huge number, right? That's not what you're supposed to do. You're supposed to take this parentheses to the 120th power and then multiply that by 500. You see the difference between this and this? You know, so make sure you don't do this, because that's not how the order of operations works. Okay, number 2. Now this time you deposit $80 a month. See, right away you can see this is a series of equal payments every month into an account with a rate of 6% compounded monthly. All right, so what is 80? That's your D. Oh, I should use black here. D is 80. This is from lesson number 8. In fact, I think this is when we had our last classroom meeting. We talked about lesson number 8. And then 6% compounded, what is that? R is equal to 0.06. Monthly means K is equal to 12. How much will you have at the end of 5 years? So N is equal to 5. All right, so the formula, which is a lot more complicated than the one you saw in lesson 7, is this. You see this huge expression here? This part has to be done first. What I would encourage you to do is to make sure you do this part first, okay? And I will show you how to do that. And then you raise it to the 60th power, because 5 times 12 is 60. Subtract 1 from it, right? And then make sure you stop just for a second and put equal sign here, okay? Right here. And then you divide this. Well, once you find out the numerator, you divide it by this whole thing, okay? Again, I have a parenthesis here. You may want to write down this number ahead of time. And I'll show you this hopefully in both ways. And finally, after everything is done, then you multiply this by 80. You get that? So just so I can color code this, I will just put this as a numerator. Oh, it goes away. All right, there you go. And then the denominator, I will circle in orange, like this, okay? And then eventually I'll multiply that fraction by 80. So the way I would do this on my calculator is this. Now you can do 0.06 divided by 12 plus 1. This case, actually, your scientific calculator knows that when you do this, it doesn't actually go from left to right. Cheap calculators will, but your scientific calculator will know to do this part first, because your calculator is scientific and it's smart, right? And so once you do this, you don't want to raise this to the power of anything yet, okay? Because if you do that, the power is going to apply only to this part. So put the equal sign here, and that's going to give you some answer, okay? And that answer will be 1 plus, 0.06 divided by 12 raised to the 60th. No, that's it. That's all you get. And then you raise it to the power of 60, and put equal sign. That's going to give you some answer. And then, of course, you subtract 1 from it, and you put equal sign. And what you get at this point is whatever is on the green. Oh, okay. That's what you get. All right, just make sure you understand this. 1 plus 0.06 divided by 12. This part is what the calculator will calculate first. Add 1 to it, and that's inside of the parentheses. You raise it to the power of 60, and then subtract 1 from it, and that's your numerator. You can pause at this point. Okay, so this will, I think I will show you this. And then the next thing I do is to divide this by this thing, okay? But what you do not want to do is divide it by 0.06 and then divide that by 12, because this part has to be done first. So your calculator should have parentheses, okay? So 0.06 divided by 12, and then you close parentheses. This will allow you to calculate the denominator as one quantity, right? And so now you are dividing your numerator by the denominator, and that is going to be equal to everything that's in here, right? And then you multiply this by 80 and equals 2, and that's your answer, okay? If you don't like this parenthesis here, you can go ahead and calculate what's inside of this orange box, and that's going to be a simple number, 0.005. And then you can write it down physically on a piece of paper with a pen or pencil, and then you can divide this green box with by that, and that would give you everything inside here. Okay, so now I'm going to move to the calculator to show you how this is to be done. Okay, so the calculations we have to do is this. It's 1 plus 0.06. Didn't work. Why? And let's go all over again, right? Okay. 1 plus 0.06 divided by 12. Okay, now again, your calculator will do this last division first, and so that answer is 1.005. Okay, and what's the next thing I'm supposed to do with this? You raise it to the power of, in this case, you had 12 times 5, which is 60. Right, and that's going to give you that factor. You subtract 1 from this, right? Follow with the operations I have written. And so that's your numerator. Now you're going to divide this by, and I will show you the parentheses method, divide it by parentheses. Notice here, this is the first set of parentheses, and 0.06 divided by 12. All right, notice here, I have the numerator divided by 0.06 divided by 12, right, inside of the parentheses. So that's exactly what I want, and that's equals to this, all right? That's everything except the first 80 on your sheet. So you multiply this by 80 to get your answer, which is $5,581.60. All right, so make sure you get that number. All right, so that answer was $5,581.60, and that is your answer. Okay, so if you have any questions, you can pause this video and you can go over the appropriate parts. And so make sure you get those things. All right, number 3. This is the last question from lesson number 9. If you want to finance $300,000 with a 30-year mortgage at an APR of 4% monthly, that's a pretty good rate. And $300,000 is sort of a typical, maybe even a lower end of a mortgage, especially in Southern California for house. What is the amount of your monthly payment? And what's your total payment? And what's your interest you pay in total? All right, so let's identify this. Here's a formula to find your payment, D. Okay, so this is, I think, maybe the last formula that appeared in lesson number 9, and that's on the video. And so maybe I should just denote this. All right. So according to that formula, which again, you don't have to memorize, but you will have to use for your homework. You will not have to use this on the exam, by the way. This is what? What's 300,000? Well, that's your principal. That's the amount of loan that you are to get. And this is also the present value of which is equal to the sum of all your future payments. And then this is, of course, R divided by K, right? That's your 4% divided by 12. This is your monthly rate, or the rate per period. Now, in the denominator, you have this complicated thing, right? So it's 1 plus that rate per period. Raise it to the negative 360. This is going to be a little challenge because depending on which calculator you are using, the way to enter a negative number is different. Okay, and I will maybe talk about this before we get into this. Once you find this denominator, you may want to write this down. Okay, of course, it's possible to do this whole calculation in one sort of a sequence, but it's kind of difficult. So maybe you want to write this down, as many digits as possible, and then you want to find the numerator and write it down. Again, physically as a number, and you want to divide the numerator by the denominator, and that's your payment monthly payment. Okay, so let me go back to what I was telling you about. So to enter negative 360, some calculators would require you to enter 360 first, followed by plus or minus. Okay, that's how you enter negative 360. Some of your calculators will have this minus sign, like especially if you have a Texas Instrument graphing calculator, you will have a negative button like this, followed by 360. All right, so maybe you can look at this ahead of time right now to see which sequence you would have to press to enter negative 360. Okay, so the way I would encourage you to do this problem is as follows. Here on the numerator, all you have is multiplication and division. So you can go from right to left. This times 0.04 divided by 12. That's okay, even though the formula says your division is to be done first, but it doesn't really matter. For the bottom line, it's much more complicated, all right? It may be better for you to, okay, so for this, here's what I would ask you, I think you should do. 1 plus 0.04 divided by 12. Again, your calculator is smart enough to know that this division is to be done first before you add 1 to it, right? And put equal sign here, and that's going to give you everything in these parentheses. And then you raise it to the power of negative 360, which in my calculator, I would have to enter this way. Okay, that's negative 360. And then put the equal sign here. And then you subtract 1 from it. I know that's not what the problem is saying. In this green box, you're supposed to subtract this thing from 1, and I am subtracting 1 from that, right? And this is going to give you a negative value. So I can go ahead and change that to the positive number by this. Because when you subtract this whole thing from 1, you get exactly the opposite of what I just did. This is all of these minus 1. Okay, so I will show you this in a moment. Now, if you don't like this, there's another way I can show you. But that's how you can get your denominator, all right? And your denominator is here, denominator is here. Your numerator is up here, you calculate it. You can go ahead and write that number down. And then at the end, you can do this divided by that, and that's going to give you the value D. So let me go into the calculator, and I will show you how this is to be done. All right, so this is the most challenging question. The numerator is, the top is as follows, 300,000. Okay, make sure that's the number you see. And times 0.04 divided by 12. That is equal to, oh, that's 1,000. Okay, so that's an easy number to remember. You can probably jot down this number 1,000 for the time being. Okay, now let's start from the beginning to find the new denominator. Denominator is a number on the bottom. All right, so it's 1 plus 0.04 divided by 12. And let's stop here first. That's 1.003333. I need to raise it to the, see this button here? Raise it to the what? 360. No, it's negative 360. On my calculator, you see this thing here? So that means to enter that negative number, I have to put 360 followed by this. And that's what you see here. Okay, so I'm going to raise that 1.00333 to this number by setting the equal sign. All right, so that is what you see as a part of the denominator. Okay, and what I ask you to do is to subtract this from 1, but instead I'm going to subtract 1 from this. So let's say do this minus 1 equals, and then this will be a negative number. That's really not what's in the denominator. But the only difference is it should be the positive side of this. Okay, in other words, I just need to get rid of that negative sign, because 1 minus that long number is actually the same thing here, except this negative number should be gone. Well, there's a quick way to make this into a positive number, all right? And that's this thing here again, all right? So I'm going to click this to make that into the positive number, which I need as a denominator, okay? And so that number happens to be 0.69820413 and so on. Go ahead and maybe you can write down the first 7 or 8 digits of this. And just go ahead and write that down. And then I'm going to go back to the beginning. All right, remember the numerator, the top number was 1,000 divided by the thing that I just wrote down, which is 0.698204, maybe that's enough. And that is equal to $1,432.25. I can round this up to 25 cents. And that is your monthly payment. Okay, I will go back and try to write it down, what we just did. All right, so you notice here, this was 1,000, the top was $1,000, 1,000, and the numerator was like 0.698204. The answer to this question was you have to pay $1,432.25 every month. All right, so that's how you can get the answer. All right, and then I will just show you, since we are in this PDF file, this is the amount you will have to pay every month. And how do you find the total payment? Well, because you are making this payment 360 times to buy that house, to complete your obligation in this 30-year mortgage, you just multiply this by 360. All right, and if you do this, you will find that you will, and again, I will show you this in a moment, you'll end up paying $515,610 in total payments. Okay, that's how you can calculate the total payment, the amount of total payment. All right, so imagine this. You're just going to borrow $300,000 to buy your house. At the end of 30 years, you end up paying $515,610. Where is the difference going? Well, the difference is what we call the total interest. Okay, so if you are to answer the question what the total interest is, then you subtract the amount of loan from the total payment, and the answer here will be $215,610. What is that? Okay, that's your overpayment. This is basically your token of appreciation for the bank or whoever is lending you the money, saying, hey, thank you for allowing me to move into this house now, even though I can't afford it, but I will promise to pay back in the next 30 years, or at the end of the next 30 years, when the 30 years is passed. Let's say you buy a house at age 25. By the time you are 55, if you don't move, if you finish your payments, then the house is yours, okay? The house for which you borrowed the $300,000 is yours, but remember, you have just paid $215,000 in the interest payments on top of the money that you borrow. You say, well, this is not fair. Well, this is how mathematics works. And this is the power of compound interest. Remember, the power of compound interest works for you when you save money, but against you when you borrow money. All right, let me go back and try to show you a way to do this on your calculator. Okay, so and I'll show you another way to get this number, the amount of payment. Right? So I know that I did this sort of strange thing in the denominator, but there is a way to do this entire calculation in one, sort of a sequence of operations without writing numbers down. And this is as follows. You can do what I'm about to show you, or you can do what I have already shown you in just the last time. All right, so the way you can do this in one sequence is this: 300,000, okay, multiplied by 0.04 divided by 12. Okay, so that is the numerator, right? Now I just click on divided by, and you can see that right here. Right. What I'm going to divide this by is the entire denominator. And because I had to use parentheses, one set of parentheses on the last time, to do this, I have to have two sets of parentheses. So here you go. Again, you can choose to do this, or you can do it the way I showed you the last time. Parentheses, 1 minus, okay, and then I have to have the second set of parentheses, the nested parentheses. You notice here on this calculator, it says, hey, this is the second set of parentheses. 1 plus 0.04 divided by 12. And then I will close the parentheses, raise it to the power of negative 360. I can see everything I've done here. Now I notice that I haven't closed this parentheses yet. That's the end of the calculation. So I'm going to close the parentheses, and everything you see here, this is the top part divided by, and this inside of the parentheses here, that's the denominator, right? And that's the same number I saw before as the denominator, right? And so then I can set equal sign, and then that will give me the answer. Right, so this number is the same as what I had before. Now, because this number is precisely how much I have to pay every month, but of course, it's got way too many digits. So at this point, I'm just going to write down $1,432.25. Okay, so that's 1432.25. That's the amount of my monthly payment. I multiply this by 360, and that would give you my total payment, which is $515,610. Okay, if I subtract the amount of the original amount of my loan, which is 300,000, this is the interest that you are paying for that 30-year period. You may think, hey, this is not fair, but what's the alternative? Basically, pay for the house cash, which most people can't do, or to live in an apartment while you save money. But if you live in an apartment, then you are paying your monthly rent, which is not buying you any part of the house. So that's a difficulty that we all have to face, and you'll have to make many decisions. Now, buying a house is actually a lot more complicated than this, all right? So for instance, your interest you pay on your mortgage is tax deductible, so you can enjoy some tax savings. You also have to worry about things like property tax payments. If things break in your house, you have to fix them, and so there are all kinds of other financial considerations you would have to make. But at least I'm showing you, exactly how the compound interest works when you buy a house. This is probably one of the most practical things you learn in this math class, and I hope you remember that as you move forward in your life, as you look at different aspects of buying a house or renting an apartment or whatever. Okay, so this is all I'm going to show you here. I hope you will have a great weekend, and I will see you next time.